Welcome back to PASC 2023 on stage. And joining me right now, we have Professor Nicola Marzari from EPFL, one of the speakers in our symposium on computer-aided design of thermoelectric materials. Tell me more about it.
Well, in general, this is part of a growing and very powerful trend in which we use high performance and high throughput computing simulations to explore material space and to find novel materials that could have powerful applications. This symposium was dedicated to thermoelectric materials that are able to convert heat into electricity, and so could be a very powerful direction to really harvest what we call waste heat that is generated but not used anymore, as it would happen when you have a turbine or when you have a major factory.
And I know this is an important trend. We've seen that at CSC as in many other sites, right? That there are many emerging trends with machine learning and wanting to train things. But I felt that historically, one of the shortcomings that people love to train things, but they rarely use it for the actual targets. To me, this sounds super exciting that it's focused on the actual application.
It's true, and myself, I'm a material scientist, so even if I am a computational person, I really get excited by the technological applications. But these days is an emerging trend worldwide in which computational simulation, and in particular quantum mechanical computational simulation, helped by machine learning, can actually predict materials' properties with accuracy, and so we use them to screen and explore, and then to work with our experimental colleagues to characterize the materials, to construct the devices.
So briefly, to the non-expert, what was the outcome of the symposium? What did you learn, or what was the common themes?
Well, we find a lot of exciting predictions, and it's a little bit like being a kid in a candy store. That is, which candy do you choose first? And in this case, it's not only a matter of choosing the candy, but even really thinking at how you actually go into a technological deployment. And so it becomes very important to work with the experimental colleagues that then at the end they need to make the bet on what could be the optimal choice among the many that we identify.
So what's the limitation? In principle, there are numerous materials one would like to design, right? But as in, the world is not perfect yet.
So in some ways, the performance of an actual materials, an actual device, is not only a matter of the actual absolute performance number, but it's a matter of the durability, how easy is it processed. And there are quantities that we can calculate very accurately, and quantities that are a bit fuzzy. So it's a bit like a Formula One car. You can have the most powerful engine, but you also need to make sure that it doesn't break up after, just the few laps of the circuit.
And I know both you and many other groups are using machine learning in this too. Yeah. How good are these methods? Can they increasingly replace quantum chemistry calculations? Or?
This is, I would say, has been the great surprise of the last few years. We always thought that quantum mechanics was so mystically difficult that it couldn't be learned. And instead, machine learning methods, and in particular in my field, deep neural networks, equivariant deep neural networks, have shown us how they can learn quantum mechanics, and they can bridge the time scale and the length scale that we always had troubles to access with a brute force calculation.
So this sounds super exciting. So based on the symposium, where are things going next? Are you coming back organizing new symposia next year? Or?
We will, hopefully for many years and years to come. I think is the integration between the computational and the experimental capability that is one of the next frontiers. Making sure that our predictions can go directly towards robotic experiments that can try some synthesis recipes and explore already in a real physical laboratory if the material work as well as we think it should.
So these new automated laboratories where you're writing Python scripts to do the experiments?
Exactly.
That sounds really cool. Nicola, thank you so much for that summary of the mini-symposium. Great. Good luck with the research and future symposia. And I would like to thank you very much for joining us. Thanks.
Great pleasure.